Hello everyone, I am Surendra, Master Teacher of Mathematics in Vedantu. In my weekly sessions on ISI and CMI preparation, for past few weeks I am taking solutioning of previous year papers. Today also I will take the latest paper of ISI, that is 2022 Part A first. Next week I will be taking Part B. In Part A we have 30 total questions which are single correct questions, not very difficult. Few questions are good. In fact, I have doubt in one of the question. I feel it is having some either language problem or it is having some sort of error. We will see that at the end of this session, towards the ends of this session. So let us start solving this paper with this question number 1, in which we are given theta belongs to 0 to pi by 2 and cos 3 theta upon cos theta is equal to 1 by 3. Then we have to find cot 3 theta into tan theta. So this will become cot 3 theta upon cot theta. Now, this question in my opinion is taken from one of the question. The motivation behind this question could be that if you remember that if you solve sine 3 theta upon sine theta minus cos 3 theta upon cos theta, this becomes equal to 2. If you take LCM in the numerator, it will become sine 3 theta minus theta, that is sine 2 theta upon sine theta cos theta, which is also sine 2 theta by 2. So this will become 2. You can use sine 3 theta as 3 sine theta minus 4 sine cube theta, and same for cos 3 theta also. Now, if we divide this equation 1 by cos 3 theta upon cos theta both sides, okay, then I think if I am dividing by this cos 3 theta upon cos theta both sides, this will become tan 3 theta upon tan theta minus 1 here, and on the right side 2 into cos theta upon cos 3 theta. So this value we are given as I think 3, because this is cos theta upon cos 3 theta, and hence we get tan 3 theta upon tan theta equal to 1 plus 6, that is 7. And what we are asked, it is just the reciprocal of it. That means cot 3 theta upon cot theta. So this will become equal to 1 upon 7, that is C is the answer. You may not do this question by this method because it is not that obvious, but the other method is also not very difficult. You can write this given expression as 4 cos cube theta minus 3 cos theta, that is a formula of cos 3 theta upon cos theta, and this is equal to 1 upon 3. And from this, if we divide by cos theta, because it should not be 0, we will get 4 cos square theta minus 3 is equal to 1 upon 3, which gives cos square theta to be equal to 3 plus 1 by 3, that is 10 by 3 and 10 by 12 actually. So that will be 5 by 6. Okay. Now what they are asking is cot 3 theta upon cot theta. This I can write as cos 3 theta upon cos theta into sin theta in the numerator upon sin 3 theta in the denominator. Already this value is given to us. Okay. Even if you do not use this equation 1 of my method 1, then also what you can do, if you use sin 3 theta as 3 sin theta minus 4 sin cube theta, and after simplifying, after cancelling 1 sin theta, it will be like this. So what we will get 1 upon 3 into 1 upon 3 into 4 into, if cos square theta is 5 by 6, sin square theta will be 1 by 6, and here it will be minus, not into, minus. So after solving this also you can check, it comes out to be 1 by 7. So in both ways this question is not difficult. I hope that is clear. Coming to that next question. We are given for any positive real number x can be expanded as x is equal to an 2 power n plus an minus 1 2 power n minus 1 and so on, a naught 2 power 0 plus a minus 1 2 power n minus 1 plus a minus 2 into 2 power minus 2 and so on, where ai are either 0 or 1, this is curly bracket, and n is greater than or equal to 0. In our described expansion of 21.1875, we have to find the smallest positive integer k such that a minus k is not equal to 0. So dear all, you can see if AI is either 0 or 1, so from this term up to this term, we will be writing, if we will be writing any possible value of AI, they will all give us integer value. Whereas on the right hand side, we will be getting, that will be after decimal. So here you can see this 21.1875, this 21 part will be coming from this first one, and 0.1875 will be coming from this one. Okay, we are looking for k such that a minus k is not equal to 0. That means we should be focusing on the later part only, not the first part. Now, I think this is not very difficult. I'll tell you another aspect of this question also. So I am writing it completely. If 21.1875 is to be written, I think we can write 21 as 16 plus 4 plus 1, which is 2 power 4, 2 power 2 and 2 power 0. And after that, we will be writing negative power of 2. You cannot write 2 power minus here because that is 0.5, which will be more than that. So if you want to write that, I think its coefficient should be 0. So 0 into 2 power minus 1. Similarly, 2 power minus 2 is also 0.25. So that also will be multiplied with 0 only. 2 power minus 3, if I write, it is 0.125, which is smaller than that. So I think we can include that with multiplication of 1, and it will be 0.125. 2 power minus 4, if we write, it is 0.0625. And you can check these two values, their sum gives us 0.1875. So that means that is what we were looking for. So 1 into 0.0625. Okay, 625. And other values will be just multiplied with 0, like 2 power minus 5 and so on. So here you can check, this is my a minus 3. A minus 3 is 1. A minus 4 is also 1. This is here. So for smallest positive integer k, for which ak minus is not 0, I think we get k to be 3. So answer will be A here. Dear all, this is actually the binary representation of some decimal number. Here if we write this in the binary form, this is 2 power 4, this is 2 power 2, okay, and this is 2 power 0. So if you write this in the binary form, it will be actually 1, 0, 1, 0, 1, 0.0011. How I have taken, this is the coefficient of 2 power 0, this is 2 power 1, 2 power 2, 2 power 3, 2 power 4, and after decimal, 2 power coefficient of 2 power minus 1, 2 power minus 2, 2 power minus 3, 2 power minus 4. So this number will have binary expansion like this, and they have modified this question. They have not said it is binary expansion of some number, but I think the question is based on that only. Okay, so now coming to next question, in which we are given among all polynomials px is equal to c0 plus c1x and so on with real coefficient satisfying mod px less than or equal to mod x for all x belongs to minus 1 comma 1, what is the maximum possible value of this? Okay, now because x is from minus 1 to 1, so naturally we can put x is equal to 0, and the logic behind it is that this x is equal to 0 will make this mod to be 0, and this will give us one very important conclusion of this question, that this mod of p0 will be less than or equal to 0, which means p0 has to be equal to 0 because this is a positive or non-negative quantity, and less than 0 is not possible. It can be only equal to 0. If p0 is 0, that means this constant term c0 has to be equal to 0. Now to talk about c1, what we can do, we can draw graph of mod x like this, and we want graph of px so that mod px lies below or just superimpose this graph of mod x. So if that is the scenario, and here on the right hand side you can check slope is 1, so the slope of px should also be at most 1 on the right hand side or on the left hand side also, because mod is there. So slope 1 or minus 1 will make both sides 1 only after putting mod there. So at x is equal to 0 at x is equal to 0, slope of this px at x is equal to 0 has to be less than or equal to 1, which here is actually C1. You can check. At x is equal to 0, slope is always the coefficient of x. You can check. So the C1, mod of C1 actually has to be less than or equal to 1. C1 cannot exceed 1. Yes, you can have C1 to be 1. One of the possibility can be that we also take Px to be equal to x. Then I think both side mod x will be there, but still it is satisfying us. And we have proved that C1 cannot be more than 1. So in order to get the maximum possible value of this, I think we should be getting C0 as 0 and plus C1 as 1 or minus 1, whatever you take, and power 10, it will be just 1 power 10, that is 1. So answer for this question has to be D. Okay, so the first part C0 was easy. Later part, that how to find C1, if you notice that this Px has to be lying below or on this graph, I think this is also something that we can do in the exam pressure also. So I will say this question was average, not difficult. Okay, now coming to next question, that is question number 4. Locus of point Z in the complex plane satisfying this is. There can be many methods. Okay, if we go by elementary methods like taking Z is equal to x plus iota y, then z square, you know, it is x square minus y square plus iota common 2xy. Whereas mod x square is x square plus y square. Now if we add them and if it is equal to 0, then we will be getting 2x square is equal to 0, that is real part, and 2xy equal to 0. That means x has to be 0. That is the condition. Y may or may not be 0, but x has to be 0. Which is nothing but y-axis, imaginary axis. So this locus of point Z will be a line, straight line, not pair of straight line, not a circle, not a parabola, A. In fact, someone can conclude it directly also by saying that Z square is equal to minus mod Z square. So this Z will be equal to plus or minus iota mod Z. Mod Z is positive real number, hence this Z will be lying on y-axis, positive y-axis or negative y-axis, including origin, because you can take Z is equal to 0 also, which is satisfying it. So this also says that Z lies on y-axis. So from here also we can conclude it that answer will be A. Now coming to next question, that is 5. Let A and B be 2 3 into 3 matrices such that A plus B whole square is equal to A square plus B square. Which of the following must be true? Now this A plus B whole square means I will be writing A plus B one bracket and A plus B another bracket, and this is equal to A square plus B square. Now if you multiply them, we will be getting A square plus AB plus BA plus B square, and that is equal to A square plus B square. As you know, matrix multiplication is not commutative in general. So AB plus BA will be 0. You cannot say that AB plus BA will become 2 times AB. We can just conclude like this only. And this is not 0, this is a null matrix. Okay, that is what we have found. Now, it is saying must be true, A and B are 0 matrices. Now it is not mandatory that A and B are 2 0 matrices. This can have, we can produce some examples where A and B both can be some non-zero matrices, and AB plus BA individually are not null matrix, and still the sum comes out to be null matrix. So this A and B doesn't seem to be correct. AB may not be 0 matrix. A minus B whole square. Now please see, this is what we may get answer. A minus B square, the way I have done it here, we will be writing A minus B multiplied with A minus B. So we will get A square plus B square minus AB minus B. And if I take bracket here, so it will be plus here. Now because this is 0, so this will just become equal to A square plus B square. So as they are saying which of the following must be true, I think D must be true. C may not be true, C is not true. In fact, it will be in special cases only. In fact, all A, B, C can be true in special cases only. But D has to be true for all possible scenarios under the given condition, this one. Okay, so this is also not difficult question. Especially, I think if it is given that it is a single correct question, that I think choosing this D as correct option is not difficult at all. Okay. Now coming to next question, that is question number 6. It says let Z denote the set of integers and f is a function from Z to Z such that fx into fy is equal to f of x plus y plus f of x minus y for all x, y belongs to Z. If f1 is equal to 3, we have to find what can be f7. Okay, now to do this question, and this is one very standard step to start these questions, such questions. So if we put x is equal to 0, y is equal to 0, we will be getting f square 0, and on the right hand side it will be 2 times f0. So this gives us either f0 will be 0 or f0 will be 2. Now if f0 becomes 0, okay, and if f0 becomes 0, then from this given definition, putting y equal to 0, you can see what we will get. We will get 0 on the left hand side and we will get 2 times fx on the right hand side if f0 is 0. Okay, so this you can see is not true because we are given f1 is 3. So this is wrong, or I should say f0 cannot be 0. So I can now say that f0 is going to be 2. Now, once we get this thing, what we can do, we can now find values of, we can find certain relations based on this. Let us put x is equal to y. If I put x is equal to y here, okay, on the left hand side we will be getting fy square as I put x is equal to y, and on the right hand side it will be f of 2y plus f of 0, which we have proved as 2. So that is one relation. Okay, one more thing I am going to do, I will put x is equal to y plus 1 here. If I do that, what we will be getting, we will get f of y plus 1 into f of y, and this will be f of 2y plus 1, and here it will be f1, which is given to us as 3 in our question. So dear all, what you can see, that value of function at any even number f of 2y can be written in terms of y. Similarly, value of function at any odd number can be written in terms of 2 consecutive integers whose sum is this 2y plus 1. Okay, now this can now solve our problem. Why I am saying like f7, if I write using equation number 2, f7 will be actually equal to, I will be putting y is equal to 3, so f of 4 into f of 3 minus 3. Let me write this as relation number 3. So f7 will be equal to f4 f3 minus 3. Now we will have to find f4 also, and f4 using relation number 1 will be actually equal to f2 whole square minus 2. f2 whole square minus 2. Now to find f2, I think there is a chain of values that we have to use. I think we can find f2 also using the same relation 1. That will be f1 square by putting y as 1 minus 2, and f1 is given as 3. So 3 square is 9, 9 minus 2 is 7. So f2 we have got 7, f4 from this we can find by putting 7 here, 7 into 7 49 minus 2, so 47. So f4 we have found. Now we just need to find f3 also, then we are done. Now to find f3, I will be using this relation number 2, which will give us this to be equal to f2 into f1 minus 3. You can check. I will put y is equal to 1 here. So 1 into 2, 2 plus 1, 3, and this will be f2 into f1 minus 3. And f2 we have found as 7 here. f1 is given as 3. So 7 into 3, 21 minus 3, so it will be 18. So this using relation number 3, my f7 will be using this third relation here. f7 will be f4, that is 47, into f3, that is 18 minus 3. Now just do the multiplication, we'll get the answer. 18 into 7 is I think 126. So 12 is a carry. 18 into 4 is 72. 72 plus 12 is I think 846. Yeah, minus 3. So that will be 843. So answer will be 843. C answer. This was a tricky question, I will say, but if you once get this this pattern, or you can find this kind of relation, then this question was also fine. But still, I will say this was average plus question under the exam pressure. Okay. Now coming to next question, that is 7. The sides of regular hexagon A, B, C, D, E. This hexagon given under this bigger hexagon is extended by doubling them to form a bigger hexagon. Okay, A, B, C, D, E is regular hexagon. So let us, this length is x here, and we are extending to form a bigger hexagon as in the given below. Achha, by doubling them, okay, that means this will also be x. Okay, in fact, this CD is also extended, so this will also be x. And here all by symmetry, I think it is not difficult to conclude that bigger hexagon will also be a regular hexagon only. Now because we know this angle is 120 degree, so this angle will be 60 degree. And this will help us to find this E dash F dash. Let me call this as Y. Using cosine rule, cos 60 degree can be written as 2x whole square plus x square minus y square upon 2 into 2x into x, and cos 60 is 1 by 2. Okay, so this 1 of 2 will be cancelled with this, and y square we will be getting 4 plus 1 5x square minus 2x square, that is 3x square. So this y will be actually x root 3. This y will be x root 3. So we have got the side of this bigger regular hexagon, that is x root 3. Now the question is ratio of areas of bigger to smaller hexagon, because both hexagons are similar. Every two regular hexagon has to be similar because all inside angles are 120. So the ratio of the areas, let me call this as, they are saying a bigger upon a smaller. It has to be the square of corresponding sides. So x root 3 upon x whole square. This will give us the answer, that is 3. So B is the answer of this question. I think this was not very difficult question. You may do by finding the area using this x root 3 and using x, then also you can do it. But I think this simple observation is much easier, much better to do this type of question. Okay. Now coming to next question, that is 8. Here we are given n1, n2 up to n12 be a permutation of numbers 1 to up to 12. The number of arrangement with n1 greater than n2 greater than n3 and so on n6. So among first 6, n6 is the smallest, and then n6 to n7, n8 again numbers are increasing. So once again you can check, n6 is the smallest among all 12. So that means I think that should be equal to 1 only. There is no other choice for this n6 to be. So this smallest, that is, it should be equal to 1. Okay. Now among remaining 11 numbers 2 to 12, okay, I think these two set of numbers n1 to n5 and n7 to n12, they have no direct relation between themselves, because we just have to ensure that n1 to n5 are bigger than n6 and in that order, and similarly n7 to n12 are also bigger than n6 in that order. So if I select n1 to n5 numbers from the remaining 11 numbers, and that will be done in 11C 5 ways. Okay, and we will be arranging them in only one order, one way, so that n1 is bigger than n2 and so on. And then I think we will be left with 6 numbers, and n7 to n12 it is also 6. So selection for n7 to n12 will be done automatically once we have selected n1 to n5 numbers. So number of ways here would be just 11C5. Okay, so you can think of this in 3 steps. Number 1, concluding that n6 is equal to 1. So doing that is just one way. Okay, then selecting, it is your choice which set of numbers you want to select first, selecting n1 to n6, or you may select n7 to n12 also. So that will be done in 11C 5 ways, and then you may like to select n7 to n12 also, but already after 5 numbers are selected, they will be selected in just one way. And then arrangement, every arrangement is done in just one way. So answer here is 11C5, whom we can write 11C6 also. So answer for this will be C. Okay, not very difficult question, one very standard problem you might have seen in your material, whatever material you are solving. I have seen this type of question in many books, and if I'm not wrong, in some previous year JEE Mains or advanced, this kind of question has been asked. Now coming to next question, that is 9. Suppose the number, the 71, 104 and 159 leave the same remainder r when divided by a certain number n. Then the value of 3n plus 4 r must be equal. Okay. Dear all, if when n divides 71, 104 and 159 and leaves same remainder, that means difference of these two, that must be divisible by n. Must be divisible by n. We can write this directly, divisible. Isn't it? Because if they leave same remainder, so if you take the difference of them, so that remainder will be cancelled out, their difference will be such that it is a complete multiple of n. That means my n must divide the difference of these two, which is I think 33. And also the difference of other two, like 159 and 104. 159 and 104, that should also be divisible by n. That is, n divides, I think, 55 here. Now if n divides 33 also and n divides 55 also, then what are the possible values? I think n can be 1, but we are given that n is greater than 1, so we will not be taking this. So what are the other possibilities? I think the only remaining possibility is n is equal to 11, because other factor of 33 is 3, but 3 is not the factor of 55. So common factor of these two is 11, so n has to be 11. And if I divide this 71 by 11, we get 6 here, 66 here, and remainder is 5. So you can check, we got n is equal to 11 and we have got r equal to 5. So what they are asking, 3n plus 4r, so that will be equal to 33 plus 20. So answer here should be 53, that is A. I think this is definitely easy question. If you've done questions of this type even in your 10th class, I think there were some questions like this. So this question I will rate as average, below average I will say. Okay, now coming to next question, that is question number 10. It says how many ways we can choose A1, A2, A3, A4 from the set A1, A2, A30 such that A1, A2, A3, A4 are in AP. Okay, now dear all, I have two methods. Listen carefully, I have two methods to do this question. One is the method that comes at first place, what should be the such number of APs. Please see. If I start taking D to be equal to 1 and then 2 and so on, because all A1, A2, A3, they are different. So at least D will be 1. So you can check my first AP will be 1, 2, 3, 4. Okay, this is my first AP. And the last AP would be, you can check 27, 28, 29 and 30. So you can see we are getting such 27 APs. Such 27 APs. We have to find in how many ways we can choose. That means how many APs we can make from these numbers. So with D equal to 1, starting with 1 or starting with 2 or and so on, starting with 27 such APs are possible with having D equal to 1. Now if D is equal to 2 I take, then my first smallest numbers forming such AP will be 1, 3, 5 and 7. and last one would be, I think, 24, 26, 28 and 30. So that last number 30 is used here. So these are the biggest possible numbers which will form AP with D equal to 2. So you can check here we are getting 24 such APs. Why I am saying 24? First was starting with 1, next can be started with 2, then 3 and so on, and the last one will be which will be starting with 24. So 24 such APs. Now I will leave this for you to identify that every time if I increase D by 1, the number of APs will be reduced by 3. Okay, you can find a logic also in this. Okay, so three APs are getting reduced every time, and what will be the largest possible D of this? Can you tell? I think it will be 8. I think 9. Let me check. If I D equal to 9, then it will be 1, 10, 19 and 28. Yeah, 1 plus 9, 10, 9, 10 plus 9, 19, 19 plus 9 is 28 and so on. And with the 9, last one could be, I think there is just a difference of 2. So 3 and then 3 plus 9, 12 plus 9, 21 plus 9, 30. So you can check there will be 3 APs that are possible with the largest possibility, that is 9. And if you add these, you will get your answer. So if I take 3 common, it is just sum of first 9 natural number. So 3 into 9 into 10 by 2. So I think this is the answer. It will be 5 into 3, 15 into 9, 135. So answer is 135. So this is one method. Now what method I was supposed to tell you? Second method, please listen carefully. Suppose A1 is A. Okay, then other numbers would be A2 as A plus D. A3 will be A plus 2D. And A4 will be A plus 3D. Okay, that means what you can see between A1 and A4, the difference has to be multiple of 3. Difference is 3k types. Difference is multiple of 3k. Okay, so what I am claiming now, that if you take any two numbers such that their difference is 3 or multiple of 3, remaining numbers we will be able to fit in. Because if you do so, your D will be integer, and if D is integer, then A2 and A3 will also be integer, and we are given all continuous integers from 1 to 30. Okay, so what I am saying, that if I make set of numbers like 1, 4, these are the numbers which are of 3k plus 1 form, 28. I think there should be 10 such numbers, you can check. Then similarly 2, 5 and so on, 29. And in the end 3, 6 and so on, 30. Now these are numbers such that difference of any two of them will be multiple of 3. For example, from first one, if you take 4 and let us say 10, two numbers, 10 will also come. So if my A1 is chosen to be 4, A4 is chosen to be 10, then difference is 6, D will become 2. Other two numbers can also be taken. They will be 6 and 8. You can check if this is A1 and this is A4, we can definitely take A2, A3 also from this one. So this question now reduces to that just select two numbers either from this or from this or from this, and they will be called as A1 and A4 respectively if they are in increasing order, and A2 and A3 can be definitely chosen. So number of ways would be that we have to select only two numbers from either this or this or this. So this will be multiplied with 3, and you can check 10 C2 is 45 into 3. If we do, we get same 135 as the answer. So dear all, this question may not be this method may not be that thinkable, or you can, I will say it is not that easy to strike in the exam pressure, but I think method 1 is just something that can be done in exam, and this pattern is very clearly seen, very clearly visible. So here we can do this question using method 1 at least, and method 2 is also something that you should do later on. if not in exam. Okay, now coming to next question, that is question number 11. It says what is the minimum value of function for real x. Okay, now dear all, there can be multiple methods of doing this question. We know this type of functions, if we are given, we can draw graph by taking values at 3, -2, -1, 0 and some number on the right and left also. But I like to draw your attention to something. Suppose first of all I'll be drawing these numbers where these expression inside mod will become 0. So I think -2 is on the leftmost portion, then -1, then 0, and then in the end it is 3. Okay, now if I take x to be on this portion, if I take x to be on this portion, that is x greater than 3. So all the mods will be opened with positive sign, and if you do that, it will become 4x plus, I think 4x only. And if leading coefficient of x is 4, that is positive, so on this portion the graph should be increasing. Graph should be increasing. Now between 0 to 3, when x will be between 0 and 3, in this case there will be just one mod, that is less x minus 3, that will open with negative sign, other will open with plus sign, and here 3 will be opened with plus sign and 1 will open with minus sign, so the coefficient of x will be 2, and there will be some constant term also which you can check, it will be I think 6. You can check it will be 6. It is not that difficult to write that also, but I am just drawing your attention towards the coefficient of x here, and because it is 2, so this is also increasing. Between 0 and -1, you can see 2 of them will open with positive sign, 2 of them will open with minus sign, so coefficient of x will be just 0. In fact, you can check, this will open with negative, this will open with negative, and these two will open with positive. So expression here would be 2 plus 1, I think this will be 2 plus 1 and plus 3, so I think 6 plus 6, so it will be just 6 here. Okay, and similarly if we go here, 3 of them will open with minus sign, so coefficient of x will be minus 2x. You can check. You can see just this one will be now left with positive sign, other 3 will be opened with negative sign. So this with negative sign, so minus 3x plus x, so it will be minus 2x, and you can check some constant term will also come. But more important thing is that between -2 to -1 it will be decreasing function, and similarly here leading term will be minus 4x, and this will also be decreasing. So you can see it will be decreasing here also, it will be decreasing. Between -1 and 0 it will be constant, and then it will be increasing, then again it will be increasing. So between -1 to 0 this will remain constant, and it will be having the value that is minimum as compared to the values in other part of this graph. So these values between -1 to 0, as you can see from this expression also, it is independent of x, so the minimum value of this function will be 6. You may like to draw proper graph, or you may like to split the mods in various cases. It is your choice. Here I just wanted to tell you that right from the leftmost portion, where coefficient will be -4, then -2, so decreasing, then coefficient is 0, so constant, then increasing and increasing. So this is how this question can be done. I think this question is not difficult, because even if you do not think that way, this kind of questions can be solved by graph or by opening these mods. Now coming to next question, that is 12. If x comma y are positive real numbers such that 3x plus 4y less than 72, then this 12xy into 72 minus 3x plus 4y, actually if I take common, then it will be minus of 3x plus 4y. So that means, and x and y are positive real numbers. So I think they're talking about AMGM. So 12 into x into y, and in this bracket 72 minus common 3x plus 4y. Okay, and this 12xy I'll be writing not like this, but I will be writing like 3x into 3y. 3x into 3y. So these are three terms whose GM I'll be taking. So power 1 by 3, and GM, as you know, it is less than or equal to their AM. AM means 3x plus 3y plus 72 minus 3x plus 4y whole divided by 3. So 3x, 3y will be cancelled and this will become 24 here. That means this given expression, let me call this expression as some P for product. So this product will be less than or equal to 24 cube. So the maximum possible value will be 24 cube. How much is 24 cube? 24 into 576. I think 24 square is 576. Yeah. So I think the unit place should be 4. I think that itself is able to give us the answer. 4 into 6. 24. So 13824 should be the answer. Let us just verify whether this is correct or not. So 4 into this, it will be 4 into 6, 24. 4 into 7, 28, so 30. 4 into 5, 20, so 23. And 2 into 6, 12. 2 into 7, 14, so 15. 2 into 5, 10, so 11. So this is 4 here, 2 here, 8 here, 3 here, 1 here. So 13824 is the answer. I think this is easy question. I will say simple use of AMGM, nothing else. Now coming to next question, that is 13. Here we are given a straight road has walls on both sides of height 8 feet and 4 feet respectively. The two ladders are placed from top of one wall to the foot of the other wall as in the figure below. What is the height in feet of the maximum clearance X below the ladders? Okay. So let us do one thing. Let us say this portion is A, this portion is B, this is A point, this is B point, this is C, this is D, this is N, and let us call this point as some P. So we have to find Pn, and I have taken Bn as A and D as B. So I think it is very easy to say that this A, B, D is similar to triangle P, N, D. And using this, what we can conclude, we can say that A plus B upon 8 for the triangle ABD, A plus B upon 8 will be equal to B upon X. Similarly, there are two more triangles that are similar. I think CDB is similar to triangle BNP. So here we will be getting A plus B upon 4 is equal to, and I think here it will be A upon X. A upon X. Let us check once again. So A plus B upon 4 is equal to A upon X. So these are the two equations which we have obtained. And to find X, I think if we just add these two, left hand side with left hand side, right with right, I think we will get the answer. So A plus B by 8 plus A plus B by 4, and on the right hand side it will be A plus B by X. A plus B we can cancel, so 1 by X we are getting to be 1 by 8 plus 1 by 4, which becomes 3 by 8. So the X will be 8 by 3. I think this is just a 10th standard problem, I will say. Very easy question. It should be done in exam. You may make a similar triangle in some other fashion also. You may do calculation in some other fashion also, but answer will be same, 8 by 3. Coming to the next question, that is question number 14. It says consider a differentiable function u 0, 1 to r. Assume the function u satisfies ua is equal to 1 upon 2r. Definite integration a minus r to a plus r ux dx for all a between 0 to 1 and all r that is less than minimum of a comma 1 minus a. Then which of the following 4 statements must be true? U attains maximum but not minimum, etc. Okay. First of all, please understand this statement. Please understand, if a is from 0 to half, then I think among this minimum of a comma 1 minus a, I think minimum will be given by a. Okay. and if a is from half to 1, then this minimum of a comma 1 minus a, because if a is 1 by 2 to 1, 1 minus a will be from 0 to half, so minimum will be equal to 1 minus a. Okay, so in both cases you can check this r is going to be lesser than 1 by 2, because this is also going to be 1 by less than 1 by 2, this is also going to be less than 1 by 2, but we have to take r based upon what is my value of a. So r will be either less than a or r will be less than 1 minus a, depending upon what is my a belonging to. Now, because we are given it's a differentiable function, and let us assume that we have taken some value of r, and this integration is with respect to x whose limits are a minus r to a plus r, and this function comes out to be in terms of a only. So if I do the differentiation using Newton-Leibniz rule, this u dash a will be 1 upon 2r into differentiation of a plus r will be just 1 u a plus r minus u a minus r. Okay, and if you notice, the left hand side is the derivative, whereas right hand side is actually average rate of change, u a plus r minus u a minus r upon 2r, that is the average rate of change as this value changes from a minus r to a plus r, in which a will also lie. That means what we are saying, that at certain value of a, the derivative is actually equal to average rate of change from a minus r to a plus r, and that too for all possible values of r, which will be either less than a or less than 1 minus a. So we are free to take multiple values of r. For example, if I say a equal to, let us say 1 by 3, if I take a equal to 1 by 3, okay, in that case my r can take value from 0 to 1 by 3. So for every r value from 0 to 1 by 3, the average rate of change has to be equal to u dash a. And this, please understand, this should be true only if this function is a linear function. I am concluding it directly. It can be concluded because this kind of thing is possible only if your function is linear. If it is not linear, you cannot have average rate of change to be equal to u dash a, and that too for infinite possible values of r. You can think upon it. So u a has to be linear function. Linear means it will be some ka plus c types, ka plus c types. Now if k is positive or k is negative, and I think ka plus c will satisfy this given relation also for all values of k and all values of c. It can be checked here. If you solve for right hand side, this integration 1 upon 2r, and integration of ka plus c will be, I think, ka square by 2 plus ca, and putting limit as a minus r to a plus r, and it can be checked after doing the calculation that it comes out to be ka plus c. I think it should have been x not a. X here and x here, and it will be the same thing. So that means every value of k and c will be satisfying it. So that means if k is positive, it will be increasing function. So at 0 and 1, it will be attaining minimum and maximum. If k is negative, it will be attaining opposite. At 1, it will be maximum. At minus 1, it will be minimum. So it will be either like this or it will be like this at 0 and at 1. So it should be attaining either maximum or minimum on the set 0, 1. Okay, or there is a possibility if k is some 0, if k is 0, then also it is satisfying it, because as I said, it is satisfying this definite integration for all values of k and c. So if if U attains either its maximum or its minimum on the set, then it must be constant. Okay, and D says U attains both its maximum and minimum on the set 0, 1. I think C is not making any sense. U attains either its maximum or minimum on the set, then it must be constant. It is not so. It is attaining minimum and maximum, but it is not constant. The phrase should have been, it will either attain maximum or minimum, or it will be constant. I think D is more closer to the answer, but it is also not complete answer, because I can choose U to be a constant function, then it will not take maximum or minimum at 0 and 1, because the values will be throughout constant. But still I will say D as the answer, because otherwise A, B, as you can see, they are saying only maximum or minimum, but not minimum or maximum. That is not possible. If it will attain some maximum, it will attain minimum also. So answer for this will be D. This question I remember was there in some other paper of ISI or CMI also. So it is kind of repeated question. In fact, I remember this was also repeated. This question I have also done recently only. So questions are getting repeated. So you can solve all previous questions for your preparation to next year, that is 2023. Coming to question number 15, in which we are given a figure ABCD is a square and triangle CEF is a triangle with sides 3, 4, 5. We have to find length BE. Now BE length we can take as X and this square side as A. So this AE will be just A minus X. Now you can see 3, 4, 5 is forming a Pythagorean triplet. So this angle will be 90 degree. Now if I take this angle to be alpha, and this complete angle should be 180, so here it will be 90 minus alpha. If it is 90 minus alpha, this angle will be alpha, and here also it is 90 minus alpha. So you can see we are getting one similar triangle AEF and this DFC, and the ratio of their corresponding sides opposite to 90 degree at A and 90 degree at D, they are 3 and 4. So I can say directly that the ratio of corresponding side length is 3:4. Now, if I take the ratio of corresponding side length, you can see side opposite to this angle alpha in this triangle AEF, it is A by X, whereas here it is FD, and that has to be equal to 3 by 4. So this gives us FD to be equal to 4 upon 3 into A minus X. So I can write this FD to be 4 by 3 into A minus X. Now because this side length of square is A, so this AF can also be calculated. AF, that will be A minus 4 by 3 into A minus X, and if we solve it, we will get this to be 4 by 3X minus A by 3. Okay, and this DC side, which is actually opposite to this angle 90 minus alpha, and upon this side length 4 by 3x minus A by 3, that is opposite to 90 minus alpha in this similar triangle, this should also be 4 upon 3. So from this DC we can calculate, comes out to be 4 by 3 into 4x minus A by 3 I can write. Now this DC you can check is also side length of this square, so this will be equal to A. So solving it, we will get 16x minus 4A is equal to 9A, which gives us A to be equal to 16x upon 13. 16x upon 13. Okay, now I think using Pythagoras theorem in this triangle EBC, we will be able to find the value of x. X square plus A square is equal to 25. So this x square plus I'll write 256 upon 169 into x square is equal to 25, which gives us x square to be equal to 25 into 169 upon this 169 plus 256, which will be 9 plus 6, I think 15, and 6 plus 6, 12, and 2 plus 1, 2 plus 2, 4. Okay, so 25 will cancel numerator, will be cancelling numerator and denominator, and it is 1, 7. 1, 7, yes. So the value of x has to be equal to 13 upon root 70. 13 upon root 70 is the answer. So A is the answer of this question. Not difficult question, I will say. And you can notice we have got one more question based on similarity. And this also I will say it's a 10th grade problem. Maybe you can say on higher side, but 10th grade only. Okay. Now coming to next question, that is 16. It says y is equal to x plus c1 and y is equal to x plus c2 be two tangents to the ellipse. What is the ratio? What is the value of mod c1 minus c2? Dear all, this question is just that we are given a ellipse x square by a square plus y square upon b square is equal to 1, and there is a line of slope 1 which is tangent to it. We know the condition for this is c square is equal to a square m square plus b square. This result we must remember, otherwise in the exam you will have to do d equal to 0. Discriminant thing will have to be done. Here a is 1, m is 1 and b square is 1 by 4. So c square we are getting 5 by 4. So c1, c2 will be, one of them will be plus sign root 5 by 2, other one would be minus root 5 by 2, root 5 by 2. So the difference of these two will be root 5, that is b. I was talking about that if you do not remember this result, then we will be putting this y is equal to x plus c here, okay, and we will get x square plus 4. We will get x square plus 4 into x plus c whole square is equal to 1. Now because this line is the tangent of this ellipse, this quadratic in x should be a perfect square. 4x square plus 1, 5x square plus 8 into c into x plus 4c square minus 1 equal to 0. Now making that d equal to 0 will ensure this quadratic is a perfect square. And from that also you can check, you will be getting c square is equal to 5 by 4. In fact, the proof of this thing also comes from this d equal to 0 only. But if you remember it, then this question you will be able to save your time. So answer is B. So I will rate this question as easy, not difficult or not average at all. Okay. Now coming to 17th question, which says n belongs to n. An we defined as this. Limit n approaches to infinity, an will be what? Now dear all, let us first solve this for n being finite. We can write this as 0 to n, 1 upon 1 plus root n into x whole square. Then this is actually form of 1 upon 1 plus x square, whose integration is tan inverse x. So it will be tan inverse root n x here, and because of coefficient of x, we will be dividing by root n also. So putting limit as 0 to n, we get this integration to be tan inverse n root n in the numerator, and for 0 this will become 0 upon root n. Upon root n. Now what they are saying, limit n approaches to infinity. Limit n approaches to infinity. So tan inverse n root n upon root n. This is what we are supposed to find. As you know, as n approaches to infinity, n root n will approach to infinity, and this will approach to pi by 2 here, whereas this will be approaching to infinite. And some finite number divided by infinite, I think this will approach to 0. So answer for this is A. Okay, now coming to next question, that is 18. P and Q be two non-zero polynomials such that degree of P is less than or equal to degree of Q. PA, PQ PAQA is equal to 0 for A equal to 0, 1 to 10. Okay. So dear all, and then they are asking which of the following must be true: degree of Q, degree of P, and so on. So you can understand PA into QA is also this, this product will also be a polynomial in A. I can call this as a capital PA. That's a polynomial, polynomial in A. And degree of P, degree of PA, capital P, degree of capital P is actually equal to degree of small p plus degree of small q. And you have seen that for PA equal to 0, for PA equal to 0, already A equal to 0 to 10, they all makes it 0. So A equal to 0, 2, and so on 10 are the roots, So we have identified already 11 roots. So I can say that PA is a polynomial of degree at least 11, has degree at least 11. At least 11. I hope that is clear. Okay. Now what they are saying, let us try to understand. Degree of P is less than degree of Q. Now they are saying must be true. Degree of Q cannot be 10. Suppose degree of Q is equal to 10. Then degree of PA, in order to be less than or equal, I think my degree of PA can be 20 also. I think if I write for A part, degree of P, let me write like this, it will be less than or equal to 20 here. If this degree is 10, if degree of Q is 10. And I think there is no problem in that, because if degree of P is 20 or even 11, then also this can be true. Same way for P also, this also we can check, but I think there is a problem in this. Suppose if P, degree of P is equal to 5, degree of Q, I think not with this C, not with this part, with C there is a problem. Let us see what's the problem. If degree of Q is 5, then degree of P will be less than or equal to 5. In that case, degree of this capital P will be less than or equal to 10. But we have proved that degree has to be at least 11. So degree of Q being 5 is not possible. So this must be true. So my answer for this question is C. You can check for B. Like if you take degree of P as 10, then degree of Q will be greater than or equal to 10. So degree of P will be greater than or equal to 20. That can be possible. Degree of P, if it is 5, then degree of Q will be greater than or equal to 5. So degree of capital P will be greater than or equal to 10. So that is also possible. We may have degree of Q to be 6, 7 or higher value. So then this condition will be satisfied. Okay. So saying degree of P not equal to 5 will be wrong, because they are saying must be true. So this question again I'll say small use of factor theorem, and that concept of how degree of a polynomial is obtained if it is a product of two separate polynomials. So this question also I will say average, not very difficult but not very easy also. Okay. Now coming to next question, that is 19. We are given number of positive integers n less than or equal to 22 such that 7 divides this. Okay. So dear all, this expression if you check in first 3 terms, n cube we can take common. Okay. And then it will be left with n square plus 4n plus 3. Whereas this 2022 is, if I divide by 7, it is 7 2s are 14, so 6, and 7 8s are 56, 7 8s are 56, so into 7, and plus I think we are left with 6 here. Okay, you can check it once again. Yeah, so that means if 7 divides this thing completely, so 7 should divide this plus 6 also completely. Okay, that means I can say that This 7 should give you a remainder of 1 if we divide this first expression. So if 7 divides, so if n cube into, and I can write this as n plus 1 into n plus 3 also is divided by 7, remainder should be equal to 1. Then only 1 from here and 6 from here, this sum will be divisible by 7. So that is all about this question. Now we have to think what kind of number n could be, and we have to think in terms of that 7k or 7k plus 1 and so on. And you can check, because if this when divided by 7 is giving us a remainder as 1, so this n cannot be equal to 7k, because then this product will be multiple of 7, and also this number can be 7k minus 1, because then this n plus 1 will be a multiple of 7, so this remainder will not be 1, and also n cannot be 7k minus 3, because then also this remainder will not be 1, because this number will be completely divisible by 7. So what we are left with now, so for n, what are the possibilities? It is 7k plus 1, 7k plus 2, 7k plus 3, 7k plus 4, or 7k minus 3 is same thing. Then I will say 7k plus 5 or 7k minus 2, that is also possibility. 3 we have already negated, so only 4 possibilities will be there. Okay, now in these cases, let us see how my n cube would be. I think in this case, n cube will be congruent to 1 mod 7. Let me write this way, congruent to 1 mod 7. And n plus 1 will be congruent to, I think, 2 mod 7. 2 mod 7. And n plus 3 will be congruent to 4 mod 7. You can check if it is 7k plus 1. So the product of these three, it is 1 here, it is 2 here, it is 4 here. So n cube will be 8 mod 7, which is equivalent to 1 mod 7. That means in this case, definitely my remainder is going to be 1. Okay, I hope you are getting it. But I am saying n cube into n plus 1 into n plus 3, with the help of that property of congruence modulo, it will be 8, or you can say 1 mod 7. So when divided by 7, remainder will be 1. So this kind of number is definitely admissible. Okay, now coming to this second one, 7k plus 2, then n cube will be congruent to I think 1 once again, because 2 cube is 8, so that will be 1 mod 1. 1 mod 7 actually. Here it should have been 7. Okay. Then n plus 1, if you write, that will be congruent to, I think, 3 mod 7. And what is left? N plus 3 here. It will be congruent to 2 will be added to 3, so that will be 5 mod 7. And if you multiply these 3, so 1 into 3 into 5, that will be 15. 15 is also 1 mod 7, so this kind of number is also admissible. So I think 7k plus 1 is fine, 7k plus 2 is also fine. Now let us do it quickly. For 7k plus 3, if I talk about n cube, so 3 cube is 27, so we will get minus 1 mod 7 for this 7k plus 3. For n plus 1, it will be 4 mod 7. For n plus 3, it will be again minus 1 mod 7. And if you multiply it, you get 4 as remainder, not 1 as remainder. So I think this will not be taken. Now similar to this 7k minus 2, if I do, so cube will be minus 8. Minus 8 means it is minus 1. And this plus 1, if you do, it will be minus 1 once again. And if you do plus 3, it will be plus 1 here. So the product will be congruent 1 mod 7. So this kind of number is also admissible or permissible, you can say. So these three kind of numbers are allowed. So we are given, we have to select from first 22 natural numbers. Number of positive integers less than or equal to 22. So for 7k plus 1, I can have 1, I can have 8, and I can have 15. And I can have 22 also. For 7k plus 2, that will be 2 here, 10 here, 16 here. And 7k minus 2, I think first number would be 5, then 12, and then I think 19. Uh, 7k plus 2 is this, 2, 10, I think 2, 9, I have made a mistake, 2, 9, and here it will be 16, that is correct. 2 plus 7, 9, 9 plus 7, 16, yeah, then it is correct. So how many total numbers? I think 4 plus 3 plus 3. So 4 plus 3 plus 3 is 10. So answer for this should be D, that is 10. Okay, this question is based on purely divisibility thing. If you understand converse modulo thing, this question is also, I will say, average, not divisible. Now coming to question number 20, we are given a 3 into 3 magic square is a 3 into 3 rectangular array of positive integers such that sum of the three numbers in any row, any column, or any two major diagonals is the same. For the following incomplete magic square, the column sum is, okay, so sum along row, 3 rows, along 3 columns, and along 2 diagonals will be same. Then we have to find what will be this sum, maybe column sum or row sum, whatever you say. Now what approach I am going to use here, you may make some equations, that is all fine, but without making that also we can do it. Please see, suppose there is some number, let us say x here. Okay, now if we go in this row and this column, sum will be same, and because x is a common number in these two, that means sum of these two and these two has to be same, and this will give us this number in this box in this center very easily. 27 plus 36 is 63, and 63 minus 31, so here we are getting 32. So we have got the number in the center as 32. Now we will be applying similar thing at this corner also. Let us say this is y here. Now you can see this 27 plus 32, this has to be equal to this 31 plus this number which is not known here. So 27 plus 32 is 59, and if we subtract 59, 59 minus 31 if we do, we will be getting 28 here. So we have got this column sum. In fact, now all remaining numbers can be found, but that is not required. We just have to add 36 plus 32 plus 28. So 60 plus 36. So answer will be B, that is 96. And you can check. You will be able to write all these numbers that are here in these boxes, and such that all the sums along rows, columns will be same. This is a puzzle I remember we used to solve in our childhood days. You might have done this question before. So I'll call this as an average question, or maybe below average question, not very difficult or average question. Now coming to next question, that is 21. We are given that 1 omega omega square be cube roots of unity. Then the product is equal to. So first bracket, if you write, I think you know this property, 1 plus omega square is equal to 0. So from this we can write this first bracket to be just minus 2 omega. Okay. Now there is one more thing. Here what they have done, they are increasing the power of 2. Like here it is 1 minus omega plus omega square. Okay, and how much will it be? Please understand, 1 minus omega square plus omega square. It is actually 1 minus omega square plus omega power 4, whom I can write as omega, and this will become minus 2 omega square. So this one will be minus 2 omega square. Okay, now dear all, what I am going to tell you next, before I go to the next bracket, please understand, if you are having sum to power n, it can be either 3k plus 1 or it can be 3k minus 1. Obviously it cannot be multiple of 3. But if you increase the power by 1, what they are doing, they are increasing corresponding power. If you compare 2 power 2 then they made it 2 power 3. Here it was 2 power 1, they made it 2 power 2. So every time corresponding term, if you compare, we are increasing in the power of 2. So if I made 2 power to make 2 power n plus 1, this will be actually 3k plus 1 into 2. And you can check, this becomes 3k plus 1, 3k plus 2 types number. It is actually 6k plus 2, which is also 3k plus 2. So every time, every corresponding term, if it was 3k plus 1, next time it will become 3k plus 2. So based on that, what I can say now, this 1 minus omega power 2 square plus omega power 2 cube. Okay, this term here was omega square. So now this will become omega. This term was omega, this will become omega square. Because 3k plus 1 becomes 3k plus 2, 3k plus 2 becomes 3k plus 1. So this way it will become minus 2 omega. So this bracket here will be minus 2 omega. So you can see every time it will be alternate. Total number of powers, if you compare, it is 2 power 1, 2 power 2, in the end it is 2 power 10. So there are total 10 brackets. So starting with minus 2 omega, I think we will be having here minus 2 omega square. So multiplying them all, we will get 2 power 10. So this product will be 2 power 10 because omega with omega square will give you 1, and this kind of pairs will be 5 times. These type of pairs will be made 5 times, they will be 1, 1, 1 every time. So answer here will be 2 power 10. I think B and D are obviously not correct. It could have been omega or omega square if number of terms would have been even or odd. Otherwise, this omega also will not come. Here we have checked if it is odd, if it is even. For if it is also odd, if number of terms, number of brackets here would have been odd, then omega or omega square could have been come. But here, because this is even, so answer will be 2 power 10. Now coming to next question, that is 22. We are given in a class of 45 students, 3 students can write well using either hand. So using left or right hand. Either hands. Okay. The number of students who can write well only with right hand is 24, more than the number of those who can write only with left hand. Okay. The number of students who can write well with the right hand is. Okay. So let us try to use this set theory concept here. So in this, 3 students can write well using either hand. So either right hand or left hand. There are total 45 students. 3 are which can write using both the hands. Number of students who can write well only with right hands. So suppose this is x here and this is y here. So I think they are saying x minus y is 24. So who can write well only with the right hand, is 24, more than number of those students who write well only with left hand. So we can write y as x minus 24. Number of students who can write well with the right hand. So we have to find, I think, x plus 3. This is what we are looking for. And also I'll assume that all students are able to write. So either they will be well with the right hand or with the right hand or with the left hand or both. So the sum of all these 3, so 2x, x plus x, 2x minus 21 will be 45 here, which will give us x to be equal to 66 upon 2, that is 33. Upon 2, not 3, so 33. 66 upon 2, 33. So this will be equal to 36. So answer for this question should be B. Actually, 33 are those students who can write with right hand only. But they are asking number of students who can write well with the right hand. So it will be inclusive of this x also and those students also who can write using their both hands. So answer will be B36. I think this question was easy based on simple set theory. Now coming to question number 23, which says number of triples ABC of positive integers satisfying the equation and such that a less than b less than c equals. Okay, now to do this question, first I will be multiplying the both sides by abc and writing this right hand side first. My left hand side will be bc plus ca plus ab. Okay, now we can make this, we can make some factors. If we write it like, please see, abc minus bc minus ca minus ab, and I will be adding a plus b plus c also this side minus 1. Then on the right hand side we will be having a plus b plus c minus 3. So this actually becomes like a minus 1, b minus 1, c minus 1 is equal to a minus 1 plus b minus 1 plus c minus 1. Now calling them as x, y and z, we are getting that product of x, y, z should be equal to sum of x, y, z. I think this is a similar situation like in a triangle 10A, 10B, 10C. And if you remember, there is one very famous, you may remember that triple, that is 1, 2, 3. 1, 2, 3 is equal to 1 plus 2 plus 3. So that is what we have got, at least one triples we have got. But now question is whether there can be few more or not. Now to do this thing, what I will say, here x is less than y, less than z. Okay, and x has to be greater than or equal to 1. Why I am saying so? Although a is positive integer and x is a minus 1, x could have been 0 also. For x is equal to 0, you can check this product becomes, left hand side becomes 0 and right hand side becomes positive. So that is also not possible. So what I am claiming, that x has to be greater than or equal to 1. Now how I am going to do, please see. One way is that if we start with x, y, z being 1, 2, 3, and if we increase the numbers, we can check that product will increase much rapid than their sum. So no other numbers can be possible than 1, 2, 3. But I will be doing a proper way. Please see how. I can say x, y, z product has to be greater than or equal to y, z. If x is 1, then it will be equal to y, z. Otherwise, it will be like this. And x, y, z is x plus y plus z. So I can say that y, z will be less than or equal to x plus y plus z. Here equality will hold only if x is equal to 1. So here I can write this as y minus 1 into z minus 1, and that will be less than or equal to x plus 1 here. Now putting x is equal to 1, it will give y minus 1 into z minus 1 is equal to 2, because then there will be equality. Okay, now if there is equality, and because y and z are bigger number than x, okay, then I think there is only one possibility, that is z minus 1 is 1 and y minus 1 is 2. So in this case we get z to be 2, and we get I think I have written it as opposite. This y minus 1 will be 1, z minus 1 will be 2. So y will be equal to 2 and z will be equal to 3. Now if I take x to be some number, let us say n, that means there will be strict inequation, and I have increased the values by n minus 1. I have increased the value by n minus 1. So y minus 1 into z minus 1 now will be less than here n plus 1. Now because x has been increased by n minus 1, so you can see this y minus 1 will also be increased by n minus 1. So this will be greater than or equal to, you can see this will be n only. Yes, earlier it was 1. In this case, if I compare this case to this case, as x is increased by n minus 1 in value, so y will also be increased by n minus 1. So this first bracket will be at least n here, and this another bracket will be at least, you know, n minus n plus 1 here, n plus 1 here. Okay, but you can see this product n into n plus 1, which is equal to n square plus 1, cannot be less than n plus 1, n square plus n. This cannot be less than n plus 1, whereas here it should have been less than n plus 1 in order this inequation to be satisfied. Okay, I am repeating. I took x from 1 to n. So, because y is greater than x, so at least that much of change should be there in y also. That much of change should be in z also. So this bracket y minus 1, if we compare from this case in which we got the solution, y minus 1 will become at least n, z minus 1 will become at least n plus 1. So in this case, this less than n plus 1 inequation seems impossible, because here n will be greater than or equal to 2, because for x is equal to 1 we have already checked. So this n into n plus 1, that is n square plus 1, cannot be less than n plus 1. Hence there is no other possibility, only one possibility is there, and hence answer for this will be C, that is 1. Now coming to question number 24, it says function in the interval has, I think one very simple question. If you take this as fx, then its derivative will be 2x into log x plus x. So taking x common, we get 2 ln x plus 1. Okay, and this will be 0 in its domain only at x is equal to, you can check, ln x will be equal to minus half. So x will be equal to e power minus 1 by 2. So in this interval 0 to 2, e power minus half, that is a positive number, and before this it will be negative, after that it will be positive. So it is having only one point of local minima, exactly one point of local minimum and no point of local maximum. So answer will be B of this question. I think that's the easiest question you can say. Okay, now coming to next question, that is 25. We are given a triangle that has side length root 5 to root 2 and root 3. Then radius of its inscribed circle is. Now dear all, please see, side lengths are actually root 5, root 8 and root 3. So you can see square of this plus square of this is equal to square of this. So this actually has become a right angle triangle. Okay, root 3, root 5 and root 8. And to find its in circle, I will like to use that formula, small r is equal to s minus a into 10a by 2, and calling this vertex as a where angle is 90. So you can check 10a by 2 will be 1, and s minus a, or let me write this as multiplied by 2 divided by 2. So this becomes b plus c minus a in the numerator by 2. 2s is a plus b plus c, minus 2 if you do, so you will get this into 1, and hence this will become equal to root 5 plus root 3 minus root 8, whom we can write as 2 root 2 upon 2. So answer for this question is D. So this question is also, I think, easy only. Coming to next question, that is 26, it says an urn contains 30 balls, out of which one is special. 6 out of these balls are taken out at random. What is the probability that special ball is chosen? I think this is also again easy question. So among 6, if you want special ball to be there, that means one ball is special and remaining 5 balls will be chosen from remaining 29. Whereas total cases would be 30C6. And if you solve it, you will be getting, I think, 29 factorial upon 5 factorial, 24 factorial here. Whereas in the denominator, it is 30 factorial, 6 factorial here and 24 factorial here. So 24 factorial is cancelled, 29 factorial will cancel it 30 times. This will cancel it 6 times. So answer is 1 upon 5, C. Dear all, I have one more method that can be much direct than this. 1, 2, 3, 4, 5, 6. These are the 6 places where we are going to find the balls and we'll be putting them. Now, my special ball can be at this place or 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 this place. Now I think they all are equally probable. Okay, so I just have to find the probability that my special ball is coming at the first place, and its probability has to be 1 upon 30. You can think of that we are just focusing on at which place I am going to get this special ball. So if it is at the first place, so its probability will be 1 upon 30. If it is at second place, then also its probability will be 1 upon 30. So if you keep adding them, you will get 1 by 5 as the answer. Okay, coming to next question 27. Here we are given x1 greater than x2 and so on greater than x10 are real numbers. What is the least possible value of this? Okay, now what you can notice, the numerator is having all terms to be same, whereas in the denominator we are having x1 minus x2, then x2 minus x3 and so on xn minus x10. Okay, so let us see how we will be going to do this. I think AMGM will be by using AMGM we can do this question. Please see, as x1 x2 the order is like this. So x1 minus x2 will be positive, x2 minus x3 will be positive, and so on. x9 minus x10 will also be positive. So taking the GM of it, so I'll be raising power 1 by 9 over it. There are 9 terms here. And if I add all of them, I think you can see we will be just getting x1 minus x10 here and divided by 9. And this is also positive number. Obviously all are positive, sum has to be positive. So we have got this x1 minus x2 into x2 minus x3 and so on, x9 minus x10. This sorry, I have made one mistake. This will be less than or equal to, so this will be less than or equal to x1 minus x10 whole power 9 upon 9 power 9. Okay, so I think we have got the answer. X1 minus x10 power 9 divided by, all terms are positive, so I can do this kind of multiplication with this inequation also. So this will be greater than or equal to 9 power 9. So the least possible value will be 9 power 9, that is C is the answer. Okay, now coming to the next question, that is 28. Here we are given two ships are approaching a port along a straight route at constant velocities. Okay, so let us say speed velocity of ship 1 is v1 and velocity of ship 2 is v2. Initially two ships and port form an equilateral triangle like this. So distance from this point to this and they are same. After second ship has traveled 80 kilometers, the triangle becomes right angle. Okay. So that means if it is right angle triangle, so this angle is 90, this angle will be 30 degree. So this length, it is d minus 80 as they have given, and they have said total distance in the beginning was d. Now if it is 30, this is 60. Using sine 30, I think we can say that this length has to be half of this d minus 80. So d minus 80 by 2 will be this length. Sine 30 will be this upon hypotenuse. So this has to be half of this thing. So that means ship 1 would have traveled d minus this thing, d minus 80 by 2. So this is actually d by 2 plus 40, you can check. Now, in the same time, ship 1 has traveled this distance and ship 2 has traveled this same distance and traveled this distance 80. So I can say this time t in which this d by 2 plus 40 distance is traveled by ship 1 will be given by this, and this will be equal to 80 upon v2 also. Okay, now what they are saying, when the first ship reaches the port, the second ship was still 120 kilometer from the port. That means when this ship 1 will be here, this will still be, such that this distance is 120 kilometer here. That means this would have traveled only d minus 120 kilometer. Suppose this is the time capital T in which ship 1 has reached to this port, and it will be d upon v1, and this should be equal to d minus 120 upon v2, because this ship 2 has traveled d minus 120 kilometer in the same time. Okay, now I think we can get this distance d by using these two relations. Just we have to do the division. If I do that, we will be getting d by 2 plus 40 upon d, and that will be equal to 80 upon d minus 120. Okay, so let us do the cross multiplication. So we will be getting d square by 2. Okay, and the term of d will be 40 from here and minus 80 from here, so minus 40d. Let me just once again check. 40d and minus 60, minus 60, so it will be minus 20, not 40, minus 20d here, and minus 12 into 4 is 4800, and that will be equal to 80d. So we are getting a quadratic which is d square. If I bring this 80d also here, it will be 100, and it will become 200d here, minus 9600 is equal to 0. I think we can split it like minus 9600 minus 160d and 40d minus, just 1 minute, it is not like this, I think 240, yes, minus 240d and plus 40d. Their product will be, you can check, 9600. So this factor would be d minus 240 is one factor and d plus 40 is another factor, is equal to 0. So we are getting d to be equal to 240, because 40 minus 40 is not possible. So answer for this question is A. Yeah. Now coming to the next question, 29. This is the question I was talking about I have problem with. So I'll be taking this question in the end. Let us first come to this question number 30. Question number 30 says range of values of this function is. If you notice in this question, fx we are given like, if I multiply by 2 and half both, numerator will become 2x square plus 4x plus 8 and 2x square plus 4x plus 9. So we will be getting this to be half common, 1 minus 1 upon this thing, whom I can write as 2 common x plus 1 whole square plus I think 7 here. Let me check once again. Plus 9 minus 1. So 1 here, 1 upon, yeah, this thing. So this is actually 1 upon 2 minus 1 upon 2 upon 2 into x plus 1 whole square plus 7. Now, as x varies over all the real numbers, you can check this bracket here will be taking values from 7 to infinity. When it will be 7, this is the minimum value of this. So one extreme of this value of this function will be when it is 7, and this will be 1 upon 2 minus 1 upon, I think it will become 14, which becomes 7 minus 1, 6 upon 14, that is 3 upon 7. And this will come with equal to sign. When it will be infinity, this will become 0. So that will be 1 by 2, and it will be with open bracket. So the value of this function should be from 1 by 2 to 3 by 7. At 3 by 7, there will be equal to. At 1 by 2, there will not be equal to sign. So answer is B. Other options are definitely wrong. Okay. Now coming to this question number 29. But for that, I will be taking few additional slides, because I will require additional slides to explain this, that what problem I have got with this question. So this question number 29. Okay. In the following diagram, 4 triangles and their sides are given. Areas of them are also given. Find the area x of the remaining triangles. So if area is 6, base is 6, area is 4, base is 6, this height has to be 4 by 3. Similarly, here height has to be 5 by 3, and here the height has to be x by 3, and here height has to be 13 by 3. Okay. Now you can check, you can notice that height of second one and fourth one, if you add, they becomes also 6. 5 plus 13 is 18, 18 by 3 is 6. Okay, so height here is also becoming 6. Now dear all, how this question has been designed, in my opinion, it is like that you make this triangle. Okay, where this is A, this is B. Now over this B, I'll put this another triangle so that this side B is overlapped with this side B. So this will become like this, and here we are having this side line to be 6 here. So C will be here. Now similarly, this triangle I'll put first here. So on the side A, I'll put this side A. So this will be D like this. And we are getting this to be 6 here, and this side length is D here. Now you can see this is D here, this is C here, which was for this unknown triangle, area of this triangle of unknown area. Now these three sides are 6, 6, 6. So if possible, if we can have, if we can say that this is also 6, then I think we will be getting a rhombus. But this 6 will only be possible if in that way what I did, this angle here and this angle here are same, then only you can claim that. Okay, now I will then refute that why it is not possible. First of all, if you remember, I told you that the height of this one is 5 by 3 and height of this is 13 by 3. Okay, so this 90 degree, this 90 degree, and sum of these two is 6. And because this is also 6, okay, so if suppose this kind of construction is possible where all sides are 6, 6, 6, and we are getting a rhombus, okay, and height is also 6, this will be possible only if this is a square. Please understand, if you have a rhombus like this, your height has to be lesser than the side. I hope you are getting it. Here you can check this perpendicular, you can take at other places also. So if this is one of the height which is perpendicular to both the sides, and it is a rhombus whose side length is 6, then it cannot be 6. So this has to be a square like this. And in one of the possible scenario, what we can do, we can have a line such that this portion is 5 by 3, this portion is 13 by 3, and there is one more triangle whose height is known to us, that is 4 by 3. Let us say this is 4 by 3. So suppose your A, B, C, D are given such that we get a point here, and this is A here, this is B here, this is C here, and this is D here. Then definitely we will be able to get the area of this remaining triangle. How we will be able to do it? I think it is very easy to say that because this is a square, okay, and area of this is 4 here, area of just 1 minute, area of this triangle is 13 here, this is 5 here, and area of these two remaining triangles should also be such that sum of these two, in which 4 is here and x is here, they should be same, because height also will be same for these two triangles. Actually, sum of heights of these two triangles should be same. So I could have done this in other way like this, that 5 by 3, not 5 by 3, this will be 4 by 3 plus x by 3 will be equal to 6. So from there you will be able to get this x to be 40. So this is how they have given this answer to be C. But dear all, my question here is, what I am claiming here, that for certain value of ABCD this is possible, but it is not possible for all ABCD. What they are saying, we are given some ABCD and they are asking the value of x. They have not said these will be some specific values. Now I'll show you why I'm saying this is not true for all such all ABCD. First of all, please try to understand, if I use Heron's formula. Using Heron's formula, this is my one equation 4 in which A and B are unknown. Then 5 is equal to another Heron's formula where B, C are unknown. Okay, and then I'll take this 13 and I am having another equation. So far you can see 4 unknowns are there, A, B, C and D. Only 3 equations are there. So finding ABCD uniquely will be a difficult task. You have to take one of A or B, then other 3 can be fixed. I hope you are getting what I am saying. So if we can only find C and D in terms of A, okay, then answer of this remaining triangle will be in terms of A. You cannot get a unique answer. That is my one way of one reasoning here. Okay, now I'll show you one contradictory example also. But before that, please understand, in this triangle, in this diagram where we formed a square. Okay, so you can see this length here should be equal to this length if any such a square can be formed. If any such square can be formed, this length here should be equal to this length, and in fact this should be equal to, as we can see from the diagram, it should be 4/3. So if I show you here, so with 13 where side length is A, this line should be equal to 4/3, and here with this also it should be 4/3. Okay, but this is not true for all possible values of A, B, C, D. I have to choose a specific value of B. For example, I'll tell you, if I take A to be 6, which I can take, okay, because they have not given any specific value of A, and let us say this angle is alpha. So in this case, I think sine alpha will become equal to, because this height was 4/3, okay, and this will become equal to how much? 4/3 into 6. So this will be 2/9. If I take this, A is equal to 6, this was 4/3, so 4/3 into 6. So this will become 2/9. Yes, okay. Now we can find B also using cosine rule now. Cosine alpha will be equal to 6 square plus 6 square minus B square upon 2 into 6 into 6. And cosine alpha will be equal to 81 minus 4. 81 minus 4 is 77/9 here. So from this you can check B square will come out to be, this is 6 into 6, 36 into 272. So I think that will be equal to 72 minus 8√77. Okay, now this height is actually 5/3. So this base here, as I showed you in that example, it should have been 4/3, but here it will not be 4/3, it will be actually B square minus 25/3, 25/9 under root of this thing. And if you put B square is equal to this thing, so 72 minus 8√77 minus 25/9, I don't think it can be 4/3. Okay, it will be actually 72 into 9 is how much? 72 into 9 is, now 9 into 2 is 18, 9 into 7 is 63, so 648. 648 minus 25, so that will be 623/9 minus 8√77. You can check the calculation. I hope this is correct. Yeah. Now I'll add just one more thing here. If you remember, I told you that this should also be 4/3. At least to make the square, we should have had these two lengths to be same. And in order to use that method, this should have been 4 by 3. And you can check. A I took as 6. Okay, this is 13 by 3. This length, if you calculate, that will be just 6 square 36 minus 169 upon 9. And you can check these two cannot become equal, because inside this under root sign there will be rational term, whereas we are having irrational term here. So in my opinion, this question is definitely having some problem. They should have mentioned that A, B, C, D are not some not any general value. It should have been some specific value so that they can form a square. But then there will be nothing left in this question. Okay, but still they have given, I think, C as the answer. So this completes the solutioning of this paper. I hope you will like these solutions of this question. Next week I'll be taking part B. Thank you so much everybody. Take care. Bye.